Okay, we're going to do the questions over solubility rules. So it says list the states of matter for each compound and then balance the equation. So first thing we're going to do is find NO3. At this point, guys, we should have worked with this enough that you're going to start to realize NO3 has no exceptions. So in this equation, this NO3 is going to be aqueous because it has no exceptions, and this NO3 over here will also be aqueous because there are no exceptions. So the other compound is magnesium chloride and silver chloride. Chlorine is soluble unless it is with silver, lead, or mercury. Well, magnesium is not silver, lead, or mercury, so this will be aqueous. But here, chlorine is with silver, and so that will be a solid. So we've identified the states of matter, and now we're going to go through and just make sure that this equation is balanced. So currently there's one silver on each side. I have one nitrate, and here I have two nitrates. So we're going to put a coefficient of 2 in front of this so that my nitrates are correct. So now my silvers aren't because I added this 2. So we're going to put a coefficient of 2 right here. And then we're going to keep checking. So right now silvers, 2 for each of those, nitrates, 2 for each of those. I have one magnesium, 2 chlorines, and 2 chlorines. So we're going to just fill in that coefficient of 1 in those 2 spots, and that is balanced. So looking at the number 21, let's identify the states of matter. So we're going to find iodine first. Iodine is down here. Iodine is soluble unless iodine is with silver, lead, or mercury. So this iodine here is going to be aqueous, and on this side iodine's by itself. So you'd have to look at the periodic table, and in the classroom iodine is black, and that is a solid when it's at room temperature. Chlorine is red on our periodic table in the classroom, so it's gas when it's by itself. It's also diatomic. And then if we look at chlorine and check to see what it is when it's with sodium, chlorine is in this soluble section, and chlorine is soluble as long as it's not with silver, lead, or mercury. So this one is going to be aqueous. And then we just need to make sure that it's balanced. So I have 2 chlorines here, and I have 1 on this side, so we're going to put a coefficient of 2. Sorry that I jumped ahead on that. If we start with sodium, my sodium's not balanced, I needed 2 here. So now I have 2 sodiums, 2 sodiums, 2 iodines, 2 iodines, 2 chlorines, and now 2 chlorines. So that one is balanced. So what is a precipitate? A precipitate is something that does not ionize in a solution. So the solid silver chloride here is the product of 2 aqueous solutions that come together and form a solid. So when 2 aqueous, I'm going to just abbreviate, solutions come together and a solid is formed. Okay, so when 2 aqueous solutions come together and a solid is formed. And 23 wants us to go back and wants us to look at 16 and 17 and identified which one would produce a precipitate. So 16 here was a precipitate, well, it's not a double replacement precipitation reaction, but when these two come together, you end up with copper solid coming out of this solution. That would be your solid, but it's not a precipitation reaction because you have a solid on this side. You don't have two aqueous solutions coming together. This is a single replacement reaction. And so that doesn't qualify. If you look at 17 though, I have two aqueous solutions that come together, and on the product side I get this solid. This will be my precipitate, and the potassium nitrate is my aqueous solution. So 17 will produce a precipitate, and that precipitate happens to be lead iodide is my precipitate that is formed. So, oops, there you go. Hopefully that was helpful.